In this video, we're going to try and integrate this from 0 to 1. That's us trying to find out this area here. But the problem is we don't know how to integrate this. So we need to turn it into a series and then integrate each individual term of the series. But the main question is how many terms do we need? 1, 2, 3, 4 and so on. How many terms do we need in order to get this area to within this level of accuracy? Okay, so we need to find out how many terms we will need to get this area to within this level of accuracy. So let's start. So let's zoom into this bit here. So let's zoom into that bit there. So let's zoom into this bit here, and then turn this into a series. So imagine this as being minus x squared. So the first term will be this. Second one would be whatever the bubble is, which would be this, and then the next one would be us putting this into here. So that will then give us this thing and so on. But we don't really need this. We can just jump straight to here. So let's jump straight to here. That will then give us this. So now it's just a matter of tidying this up. So looking at this bit here, imagine this as being negative 1 times x squared, and then this would be minus 1 to the power of n. So it would be minus 1 to the power of n, and then this times this, that would be x to the power of 2n. So this thing here becomes this. Okay, and then now so this thing here is this whole series here. So now we need to integrate it. So integrate this, and then integrate this whole thing here. Remember, we've done this before. You can actually integrate a summation. So when you integrate this, the power here gets added by 1. So this thing here will become 2n plus 1. But it's just like this, x to the power of the x squared. Say if you integrate it, it would be this. It would be this. So the power gets increased by 1, and then you've got to divide it by whatever's over here. You've got to divide it by whatever's over here. Okay, so well anyway, we've done this before. So integrate this. That will then give you this. So the integral will be this whole thing here from 0 to 1. So when you look at this, you've got to imagine this as being a sum. So you've got a fraction here. This is like a fraction. You've got a fraction. When you look at this, imagine it as being a fraction. Take away another fraction. Add another fraction. Take away another fraction, and so on, all the way to infinity. All the way to infinity. So now, hang on. So now you've got to do this. Put 1 into here. Put 1 into here. Put 1 into here. Put 1 into here. All the way to infinity, and then you've got to put 0 into here, and then you've got to take away, and then 0 into here, 0 into here, 0 into here, and so on. But the thing is, when you put 0 into here, because this contains x here, when you put 0 into here, it will be 0, because this whole thing here will be 0. Therefore, the whole thing here, it will be 0 over 1. So it would be 0. Put 0 into here, it will be 0. Put 0. So because it's 0, you can forget about it. And when you put 1 into here, when you put 1 into this x here, this will become 1. So that's this one here. And then when you put 1 into here, when you put 1 into the second term, when you put 1 into here, again it's still going to be 1. Put 1 into here, it's still going to be 1. So you're always going to get this. Okay, so integrating this will then give us this. Okay, so now I will continue in the next video. Okay, so we are currently at this stage here.